This set of notes covers inequalities and systems of inequalities and the solutions to those systems. Very, very similar to equations where there's an equal sign. The difference is in the end, when you're reading the equation, you're really looking to see if the equation is true, not always equal. So it might be a true statement like 8 is less than 6. Well, that's a true statement, so it might work. So let's do some practice examples, and then it'll start to set in and make more sense. So for here, it's asking, is 4, 6 a solution to the system of inequalities? So you're going to plug 4 in for x and 6 in for y to see if both statements are true. So I have two equations, y is less than or equal to x plus 2, and y is greater than or equal to 4. So if I'm plugging 4 in for x, and I'm plugging 6 in for y, I know that this is a true statement. 6 is definitely greater than or equal to 4. And 6 is less than or equal to 6 is also a true statement, meaning 6 is not less than 6, but it's equal to. Just like 6 is not equal to 4, it's greater than. So since you have the greater than or equals to symbols, you're able to say that yes, 4, 6 is a solution because it's one of the points that would fall within the shaded region, which we'll get to next when we graph, of these two equations. So go ahead and pause the video and try this on your own. So x is 4, and y is 6. Is 6 less than or equal to 8? And is 4 plus 6 less than 4? These are the original equations. 6 is less than or equal to 8. 10 is not less than 4. So this would not work. That would be no, the solution 4, 6 is not a solution to those two equations. Another example would be where you have two more complex equations, same process. So we know x is 1 and y is 3. So I have my two equations. 9x plus 3y is greater than or equal to 18. And x plus y is less than or equal to 2. So if I plug it in for x, 1, and I plug in for y, a value of 3, the question is, are both statements true? So here we've got 9 plus 9. Is that greater than or equal to 18? Yep, because 18 equals 18. But here, is 4 less than or equal to 2? No. So since one of the equations does not work, 1, 3 is not a solution to the system, of inequalities. Whew, there we go. So go ahead and scroll down to the bottom. Scroll as if you're like on a computer. So look at the bottom of the page and try practice problem 2 on your own. So go ahead and pause the video. So if x is negative 4 and y is negative 3, ooh, this is going to be some icky math. I'm just copying the equations. So 11 times negative 4 minus 12 times negative 3. 18 times negative 4 minus 16 times negative 3. Negative 44 plus 36 is greater than or equal to 20. Is negative 8 greater than or equal to 20? No. So the second I get a no solution, no means no. So there would be no way that this system could be a solution to the inequalities. So you would put no. You don't even need to solve the second one unless you want to. But if you double check your results from the first one, you'll still see that it's a no. You only need one no for it to not work. And here's a third practice problem for you to try. So go ahead and pause the video and try this last one. If x is negative 7 and y is 2, I cannot do 16 times negative 7 in my head. That's like mean. Negative 112 plus 20. Why did I give that a negative? That should be positive. Minus 26. Negative 112 minus 26 is going to be negative 138. And that is going to be a false statement. So we already know without even doing the second equation that this is not going to be a solution. Negative 7, 2 is not a solution to these two inequalities. So there'll be a lot of work to show for this section, but it's pretty straightforward. Just make sure you pay close attention to your math.